Hi guys, this is Vineet, and in today's video we will cover the TempDB database, and this is our database design video. So we will talk about TempDB database in SQL Server. Before we proceed ahead, I would request all you guys who have not subscribed to my channel to please go ahead and immediately subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button and it will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. Now, let's move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept. And if it's possible for you, please watch this video twice or as many times as you like until your concept gets clear. Please perform any exercises in your lab environment only or the test environment only. Do not touch any production environments or production databases. And we would like to know your thoughts regarding our videos, guys. So please do share your comments. Do share your experiences with us regarding SQL Server. Do let us know about those situations where the content in our video has helped you somewhere in your day-to-day situations. Also, guys, you can post in your suggestions, etc., to us as well via the comments. We wait for your comments, and we would love to read them. And would like to know your concerns. I've curated some playlists for you to watch. Some of the playlists are database design playlist, SQL Server table playlist, business continuity playlist, indexing playlist, performance tuning playlist, and the integration services playlist. This video will be part of the database design playlist, which already has like 59 videos. And we have more than 170 videos hosted on our channel. So please watch all of them out. And also I have a channel page, link is included in the description. Also the link is included for all the playlist in this particular video description. So check out the video description area for all the playlist link and the channel page link. Give me a minute, guys. Alright guys, let's continue. So I was telling that all the links for the playlist are included in the video description area. Check them out. And also my channel page link is also there in the description. When you go to my channel page, you will find all these playlists there as well, so you can check all my playlist from there as well. The best way to study a particular topic is going through all the videos in a particular playlist. For example, if you want to learn about integration services, I would recommend going through all the videos in the integration services in a one by one manner. And same is true for other playlists as well. So if you want to learn about database design, go through all the 60 videos posted on that playlist one by one to gain better idea about the work in the database design area. Now let me move back to today's topic, and today we are discussing about the TempDB database. Let me go to my notes page. We will write notes along with whatever I'm telling during my lecture on this topic. So let's continue. So let's talk about TempDB. Okay, so what is a TempDB? So first of all, if we talk about TempDB, it's a system database, right? So TempDB is a system database. However, it is not. I think it is visible in the UI. So let's quickly check it out whether this database is available under the system databases section. So just invoked SQL Server. Wait for it to load. Once it opens, I will connect to a default instance of the SQL Server, and we will try to locate this particular database. So let's connect to the SQL Server default instance, and here under the databases section you will see system databases. If you expand the system databases section, you will see TempDB over here. So we are talking about this database. So let's continue with the theory. So TempDB, first of all, is a system database. Also, it's a global resource. We can say it's a global resource that is available to all the users connected to an instance of SQL Server. Alright, so whosoever is connected to the SQL Server, this global resource, which is TempDB, is available to all those users. Now, let me take you through the overview of TempDB database. So first of all, we have discussed that it's a global resource available to all the users. So what does it hold? So what does it hold? So let's cover this topic. What does TempDB holds? Right? Let me properly emphasize the heading. Let's take it as yellow, uh, bright yellow maybe. Standard color we have yellow. Okay, let's take it as yellow. The color is not coming appropriately. Let me mark it with some other colors. So let's take this color. So we are talking about what does a TempDB holds. So it contains the temporary user objects that are explicitly created. Like we create temp tables or temp variables. These are temp user objects that we explicitly create. We create temp table as well. So those are all temporary objects. So all these objects include, so they include basically the global or local temporary tables and any temporary indexes as well. Any temporary stored procedures can also be created. All are stored in the TempDB database. So apart from temporary stored procedures, we have table variables that are temporary, and we have tables returned in table valued functions. So those are also stored as temporary objects, and cursors are also temporary objects that are stored in the TempDB. Now, apart from temporary user objects, what other object does it hold? So it also holds any other objects, any other internal objects, we would say, that the database engine creates. All right, and these basically include. So these include. So any internal objects can include work tables to store immediate results for spools, cursors, sorts, any sorting operations, and temporary LOB storage. By LOB we means large object. Give me a math, guys. So guys, I'm back. So it also the TempDB also stored any internal objects that the database engine creates, and these objects include any work tables to store immediate results for spools, cursors, sorts, and temporary LOB storage or large object storage. It also stores any work files, maybe work files for hash joins. We'll talk about them later if you are not aware about the hash joins. So any work files for hash joins or hash aggregate operations. These are also stored in as internal objects in the TempDB. Now it also stores any intermediate sort results. Those are stored in TempDB. So sort results can be for the operations such as creating or rebuilding indexes. So whenever we create or rebuild indexes, a sort operation occurs. So all those immediate during that sort operation, all the immediate sort results are stored in the TempDB, and this happens during the creation or rebuilding of indexes. So this only happens if clause sort in TempDB is specified. If this clause is set to true, then only the sorting is sorting happens in the TempDB, otherwise not. Any group by operations, any result of the group by operations are also stored in TempDB, or maybe order by clauses, result of order by clauses are also stored in TempDB. Any unions we do, any union queries we perform, the results are stored in the TempDB. And if we talk about this internal objects, let's talk about these internal objects. Each internal object basically uses minimum of 9 pages. A page is basically a unit of storage in SQL Server, so an internal object uses a minimum of 9 pages. So these 9 pages includes an IM page. We'll talk about that later in much detail. So it includes an IM page and then 8-page extent. So extent is also a unit of storage in SQL Server. So a page is also a unit of storage in SQL Server. So one extent is equal to 8 pages. And we will talk about pages and extents in our upcoming video. So stay in tune, and if you have not already subscribed, please subscribe to our channel. Now, so far we have discussed that the TempDB stores the temporary user objects that are explicitly created, or any internal objects created by the SQL Server database engines during any sort operations, or any of the intermediate result sets, or any results from group by, order by, or union queries. Now, what other things the TempDB can store? It also holds the version stores. We will talk about them later. What are version stores? So version stores are basically, if we can say, these are collections of data pages that hold the data rows that support features for row versioning. So we will talk about the row versioning concept later. So any of the version stores are stored in TempDB, and version stores are basically a collection of data pages that basically holds the data rows to support the features like row versioning. And what type of version stores are available? So there are two types of version stores that get stored in TempDB, I would say. One is a common version store, and another one is online index built version store. So these are the two type of stores that get stored in the TempDB. Okay, now what does this version stores hold basically? So let's talk about them. The version stores holds. So what does it hold? It holds row version, as we talked earlier, that are generated by data modification transaction, I would say. in a database that uses read committed. So if you are not getting an idea about this, guys, if anything is keeping your head at this point, that's fine with us. We will cover about the row versioning later on in our separate video that will get this idea more clear. So basically, we are discussing in this video the main idea is to grasp what all things get stored in the TempDB. So we store any temporary user objects, we store any internal objects created by the database engine, and apart from that, we store the version stored data. And we are talking a little bit about the version stores here. If you're not getting mm, a good grasp on version store here, then you can wait and watch out for my upcoming videos on version store that will give you more clarity in this. So row versions that are generated by data modifications, transactions in the database that use read committed, these get stored in the TempDB. So that uses row committed through row versioning isolation. So this concept is not yet clear to you. So we will talk about row versioning, what is row versioning and what is row versioning isolation in our upcoming videos. So snapshot isolation transactions as well. So basically here we have defined how the row versions get generated. It basically gets generated by any data modification transactions in the database that use any read committed through row versioning isolation or snapshot isolation transactions. And also row version data gets generated by so TempDB holds any of the row version data generated by data modification transactions for any features such as online index operations, multiple active result sets, which is also known as Mars, and the after triggers. So these are all things which get stored. Basically, the row versions data gets stored in the TempDB database. That is what you have to grasp here. Don't go into much detail here, although I've discussed it. But yeah, if you're not getting that, that's okay with us. All right. Now the operations within the TempDB are minimally logged. So that is the key point. So far we have discussed what TempDB is, what it holds. So we are covered with this topic. What does TempDB holds? All right, now let's continue with general discussion on TempDB. So one of the point is that operations within TempDB are minimally logged. So there will be minimal logging for any operations. So any operations within the TempDB have minimal logging. So that why there is a minimum logging, so that transaction can be rolled back easily. All right. And basically if we talk about TempDB, TempDB gets recreated every time. So it gets recreated every time SQL Server is started. So whenever we start SQL Server services, it recreates the TempDB altogether. Or whenever we reboot the server, it also and launch the SQL Server, the TempDB gets recreated at that time. So whenever a SQL Server is started, TempDB gets created. We got this idea. Basically, it gets recreated every time SQL Server is restarted. So that why this happens? So that system always starts with the clean copy of the database. So that is the reason why SQL Server always starts with a clean copy of a TempDB. So that system should start with the clean copy of the database. So that's why the SQL Server recreates the TempDB every time the SQL Server services are restarted. And whenever the session is disconnected, so what is a session? Basically, whenever we trigger a query against any database. So for example, if we select AdventureWorks TW 2022 and invoke a new query, it creates a session. So any temporary things created within this session is valid for this session only. So this session has a session ID number given at the bottom. So given above, I can say. So 53 is the session number here. If you watch it out here carefully in the header, you see 53. That's the session number for this query. So any of the temporary tables that we create in this window or that get created via this query window are dropped automatically on disconnect. So how do we disconnect? Whenever we close the query, we will lose out on those temporary tables automatically. And if any connection becomes inactive as well, and when the system gets shut down, the temporary objects get dropped automatically, and the TempDB gets disconnected. Now, so the point we missed is temporary tables and stored procedures gets dropped automatically. All right, on disconnect. By disconnect we mean disconnect of a session. All right. And SempDB basically never has anything to be saved from one session of SQL Server to another. And the one thing is that backup and restore operations cannot be performed on TempDB. All right. Now let's talk about some of the physical properties of TempDB in SQL Server. So what we will see the properties of the temp data and log files in SQL Server. And the values are based on the defaults for the model database. Maybe it can be changed later on as well. And the size of files may vary as well uh, between the different version of SQL Server as well. So let's see the size of the, let's check the properties of TempDB here. So if we take a look at the file section, so in our environment, we have many TempDB files. So we have around, I would say, 8 TempDB files, which are which are created in the primary file group. So first file size is 50 MB. Rest of the files are 8 MB in size. And apart from that, we have a temp log file as well. And the temp log file has a size of 25 MB at present. And all has an auto growth setting of almost each one of them is growing by 64 MB. And they are not restricted. They can grow unlimited. And the first initial file auto grows by 1 MB and the maximum size is unlimited. And the temp log, the same for temp log as well. The initial size grows by 1 MB and it's unrestricted. It can grow till the disk space can get exhausted. Now here we have 8 second. So we have one primary data file and multiple secondary data files as NDF extension. So we have 7 NDF files, 1 MDF file. MDF is a primary data file, NDF are secondary data files. We have 7 secondary data files. So the number of secondary data files depends upon the number of logical processes on the machine. So how many secondary temporary files we have? It depends upon the number of logical processor on the machine. So let's see how many logical processor we have. So if we open the task manager over here and go to the performance tab, over the right hand side you will see that we have 8 logical processors. So the number of temporary files can be 8. That is how the number of temp file, how many temp files will get used, will depend upon the number of logical processors on your machine. So we have 8, right? We have just shown you. So that's why we have 8 temporary data files. Now, as a general rule, if the number of logical processor is less than or equal to 8, so we have this condition true. So if the number of logical processor is less than or equal to 8, use the same number of data files as logical processors. So this configuration is correct. So we can use 8 files in total. All right. So this configuration looks correct. Now, if the number of logical processor is greater than 8, then always use the 8 data files, not more than that. Then if contention continues, so if any kind of contention occurs, increase the number of data files by multiple of 4 until the contention decreases to acceptable levels, or make the changes to the workload or code. The default value for the number of data files is based on a certain KB. You can check that out. So we are fine over here. So let's not get into much detail here. We will cover that out in our later videos if any further details are required. Now to check the current size and growth parameters of TempDB, we can use the query view. Let me show you that. So we can change the check the growth parameters from here as well. So same thing can be determined from a query view as well. So how to check that? So if we open up a new query window, what we can do is we can do select star from. There's a tempdb dot sys dot database. Sorry guys. So tempdb dot sys dot if you query this view database underscore files. This is the view you can query to get the current size and growth parameters. So all the files for TempDB are here, and the name are given, actual names are or logical names are given over here, and the physical file names are given over here. These are secondary data files, right? And status is also coming over here. So keep remember this view, or you may note it down, tempdb.sys.database underscore files. Now it shows us the initial size, the growth, what is it is set to, the increment growth, and whether it's restricted or not. So I think this is fine. And max size is set to -1, which indicates unlimited growth. And this is the growth parameter specified by the growth column, and size is the initial size of the file at the time of creation. Now TempDB data and log files can be moved as well. We will cover that out in I think we had already covered that out in one of my previous videos where we moved the system databases, so we are not covering it here. Now let's discuss about the database options that are available for the TempDB. I won't go into much detail, but let me just show you the list of database options available for TempDB. So let's query a view which is sys.databases. All right, so let's query this view. Let's see what do we get. So All the options are available here, but yeah, we need it for TempDB, so we can set where name equals TempDB to just get the values for TempDB. So we have multiple settings, so I can discuss few of them, but yeah, not all of them. So first setting is, let me take it in first column. So allow snapshot isolation is one of the setting. Let's see if we have this setting available for TempDB. Uh, Allow snapshot isolation. Not sure. Let's see. So this column is not available. So other settings are available. So let's check what all settings are there. So let me take one by one. So like we have is read only option. Let me see if any other. Let's see if we have. So one of the option we can discuss is auto shrink on. So auto shrink by default it is set to 0, which means off. We can turn it on as well. So this setting can be modified as well. You can check out this table online. One of the other setting is, apart from auto shrink, is so standby is another option. Let's see if we have that option available. So I think it's not available. So let's see what other. So we have another option, cleanly. So standby option is here. Cleanly shut down. So here is the snapshot isolation state, and the state description is given over here. So by default, the snapshot isolation is off on this database, and description is given over here. This option can be turned on as well. So yeah, these are the two options we are discussing. There are many other options. You can check all of them out online. I'm not going to discuss each and every one here. So these are some of the options available for TempDB. Now let's talk about the TempDB in SQL database. Let's go to notes. Give me a second, guys. Now let's talk about some of the restrictions that are applicable to the TempDB. So what are the restrictions applicable? So the following operations cannot be performed on TempDB. So what are these operations? So first operation, we can say we cannot add file groups. So adding file group is not allowed. Backing up, backing up, and restoring of database is not allowed. We cannot change the collation. So changing collation is not allowed. And the default collation is the server collation. And we cannot change the collation of TempDB. Now, changing the database owner is not allowed. We cannot change the database owner for TempDB. So if we say TempDB is owned by SA as default, we cannot create a database snapshot. So creating a database snapshot is not allowed. Another thing which is not allowed is we cannot drop this database. Dropping a database operation is not allowed. We cannot drop TempDB database. and we cannot also drop a guest user from the database, from the TempDB database in particular. And we cannot enable change data capture, which is a concept we will discuss later. So change data capture cannot be enabled on a temporary database or TempDB. This database cannot participate in database mirroring operation. We cannot use this database for database mirroring. Removing the primary file group is not allowed in this database. Removing of primary file group is not allowed. Removing of primary data file is not allowed, or any of the log file removal is not allowed. Renaming of this database is not allowed, or renaming of any primary file group is not allowed. We cannot run dbcc check allocation command against this database. We cannot run dbcc check catalog command against this database. We cannot set this database to offline mode. We cannot set the database or primary file group to read only. So these are some of the restrictions that are applicable on the TempDB. We cannot perform these operations. So I hope you have jotted down the notes. All right, so let's move ahead from here. So what are the permissions required to create objects in TempDB? So any users can create temporary objects in the TempDB database. Users can only access their own objects unless they receive additional permissions, and it is possible to revoke the connect permission to TempDB to prevent a user from using TempDB. So these permissions can be revoked by the system administrator. So a system administrator can revoke permission for any of the users to access TempDB so that they cannot use the TempDB. And basically this practice is not recommended because some routine operations require the use of TempDB. So a system administrator should not be doing that. Like revoking the access for a particular user to use TempDB. He should not be doing that. Now, let's talk a little bit about the how we can improve the or how we can optimize the TempDB performance in SQL Server. Let's talk about optimize TempDB performance in SQL Server. Let's make this heading. Okay. So how to optimize the TempDB performance in SQL Server? So let's discuss some of the points under this topic. So basically if we talk about the size and the physical placement of the TempDB database. So what's the size of the TempDB database and where its physical files are located can affect the performance of a system. Now let's take an example. So for example, I would say if the size that is defined for TempDB, if it's too small. So I'm taking an example where we have defined the size of the TempDB as too small. So what happens if we define TempDB as too small? Then part of the system processing load might be taken up with auto growing TempDB. So in case the initial file size for the TempDB is small, that it can result in creation of new files altogether, right? So any part of the system processing load might be taken up with auto growing TempDB. So first of all, it auto grows the TempDB up till its max size, right? TempDB to the size required to support the operation, support the workload, I can say, or operation. Every time you restart the instance of the SQL Server. So let's omit this line. So TempDB autogrows depends upon how much the workload is. The file size gets grown automatically, and the size of the TempDB basically affects the performance of the system, and the physical placement of files also affect the performance of the system. And there is a concept basically, and if it's possible for you, always use the instant. The concept is instant file initialization to improve the performance, growth, operations for data files. So whatever initial file size that we defined for TempDB should be large enough so that it should not auto grow during the time as per the workload. So it should have a static size, some initialized size should be there, maybe 200 MB, 300 MB, depending upon your workload, how much workload you have on your system. Now, what do we do basically? What we should be doing basically. So we would suggest pre-allocating. Let me change the color. Let's try to write with a different color. So let's take this blue one. So I would say pre-allocate space for, sorry guys, I think I have zoomed it out. Sorry guys. I don't know what has happened, but yeah, let me see what the zoom level is. I think this one is more, so I think this should be okay. All right. Let me increase the size a little bit. Okay, this one is fine. So the suggestion is to pre-allocate space for all TempDB files. So we should do some pre-allocation of space to the TempDB files by setting the file size value to a value large enough to accommodate the typical workload in the environment. So we should do some pre-allocation of space. For example, if we think that our let's take a look at properties of TempDB file. So if we know that our TempDB file can take up to 300 MB of space whenever we put some load on the SQL Server, then we can set the initial file size to 300 MB instead of just keeping it at 50 and doing an auto growth by 1 MB till the disk size is full. So auto growth is a resource intensive operation, so we should avoid that. we should size the file appropriately at initial state. So if we think 300 GB is sufficient enough, we can size this file as 300 MB. And same is true for other files, the 8 files allocated here. We can set certain good amount of size for each file so that we should have ample space for handling our workloads. All right, and let's go back to notes. So we're talking about pre-allocating spaces for all TempDB files by setting the file size value to a value large enough so that it can accommodate your workload in the environment. And what is the benefit of pre-allocation? So pre-allocation basically prevents the TempDB from expanding too often. All right, which affects the performance. So it will not perform auto growth operation every time we put a workload on a system. If it has a good size, good initial size of the file, then it will not usually auto growth do auto growth on itself if we have a good initial file size defined. So basically, the pre-allocation prevents the TempDB from expanding too often, and this will basically affect the performance. And the TempDB should always be set to autogrow to increase disk space for unplanned exceptions. So this is another good point. So take a note. So what should we do? The TempDB database should be set to autogrow. So if we take a look at current environment, the files are set to autogrow by 1 MB. So it should be set like that. It should be set to autogrow to increase the disk space for any unplanned exceptions. So auto growth settings are for any unplanned exceptions. So we should define a good amount of initial size, and apart from that, we should configure the auto growth settings as well for any unplanned exceptions. And auto growth size also should be sufficient enough. So right now it's configured as 1 MB in our environment. Because this is a test environment, it's okay, but for any production environments, the auto growth size should be more, right? So you need to plan accordingly as per the workload of your environment. Now data files should be of equal size within each file group. So if we take a look here about the files, if we take a look at the files, the data size is not equal. So first one, if we say the data file size is 50 MB. So ideally, if we are using 8 data files, all should be set to 50 MB. So this is a test environment, so that's okay for us. But ideally, if it's a production environment, the size of all the TempDB files should be, or whatever the files are there in the same file group. So these all 8 files are in the primary file group, if we see here. So all of the files that are under the same file group should have a same file size. All right. So data files should be of a equal size within each file group, because SQL Server uses a proportional fill algorithm that favors allocation in files with more free space. So how SQL Server fills the data files? It basically fills those files first which have more free space. And dividing TempDB into multiple data files of equal size provides high degree of parallel efficiency in operations that use TempDB. So if we have 2 files within the primary file group, and one file is almost like 75% filled and another one is only 25% filled, then the SQL Server will prefer filling out the file which is 25% filled. So that basically prevents any kind of parallel efficiency, that does not provide any parallel processing or parallel efficiency. So that's why it is recommended to keep the data size of the files that are in same file group to be of same size. So let me write that down. That's also another very important point for the performance. So data files should be of equal size within each file group. So for TempDB, we have 8 files in primary file group. So each one should have a same file size if we are in a production environment. And why is that so? Why should we keep the same size? Because the SQL Server uses the proportional fill algorithm. Let me write that properly. Proportional fill algorithm that basically, and this algorithm basically favors allocation of data within the files with more free space. So whatever files have more free space will get filled first. And basically dividing the TempDB into multiple data files of equal size, what benefit does it provide? It provides a high degree of parallel efficiency. All right. And it provides the high degree of parallel efficiency in operations that use TempDB. So if all the file sizes are same, all the files get filled at the same time by the algorithm while doing any operations that require the TempDB. So that is useful. That's why we should keep the same file sizes for any of the data files for TempDB that are in same file group. All right. And set the file growth increments setting to a reasonable size and set it to increment at the same level for all the data files. So that is another good point. Let me change the color a little bit here. Oh no, this will be a good color. Okay, it's good. So I would suggest setting the file growth increment to a reasonable size. So file growth size should be reasonable. And basically it is set to set it to the same increment for all the data files to prevent the TempDB database files from growing by too small a value. So in our environment, we are growing it by 1 MB, which is not appropriate for any production environment. So this size should be good. So the other files are incrementing by 64 MB, which looks okay, but the first one is incrementing by 1 MB, which is not good. Also, the sizes are not same, which is not correct. As per the production environment, it's not correct, but yeah, test environment can take anything. Let's go back to notes. So auto growth setting should be same for all the files, and it should have a reasonable size so that it should not grow by a too small a value. And if the file growth is too small compared to the amount of data that is being, so why is that so? Why should size be the reasonable? And auto growth increment setting should be of a reasonable size. If the file growth is too small compared to the amount, sorry guys, compared to the amount of data that's being written to TempDB. If the autograph size is smaller than that, compared to the amount of data that is being written to TempDB, then TempDB might have to frequently expand via autogrowth, right? Autogrowth events. And basically, these autogrowth events negatively impacts the performance of the system. So we should have a reasonable size for auto growth increments. That's the reason. And there is a query which we can use to check the there is a query which we can use to check the size and growth parameters for TempDB. We can write that down. So let me write that query down for you. Otherwise, you can check all the setting via the properties as well. So those settings are available as well. But yeah, you can check these settings out via query as well. So let me write that down for you, and you may write it down as well. Along with me, we will run this query. So let me write that down. Tf.file and we are selecting the data from there's a tempdb dot sys dot database files view, which we were discussing about earlier. So we are taking it as df. So we are taking the file name as df.filename from the view, right? And we are taking the current file size as basically in MB, I would say. And we are defining the df size column we are taking here, and we are multiplying it by 128. 1.0 divided by 128, that will gives us the size in MB. And let's take the max size as, now we are defining a case parameter over here, and we are pointing it to the df dot max size values. So let's put an end here, and let's define this case quickly. So max size, when the max size is set to 0, then we can specify that auto growth is off. Else, when it is set to -1, it means that auto growth is on. All right. So apart from that, let's take the growth value, which basically defines the increment settings. Here also we are taking the case statement. So let's take a case and then end. So case we are taking as when the df dot growth is equal to 0. Then we can take the actual value df dot growth, and when we can say df dot growth is greater than 0, then we can take df dot, so second condition we are taking is if df growth is greater than 0 and df is percent growth equal to 0. Then df dot growth, take the value df dot growth into 1.0 divided by 128.0. And let's take another condition when df dot growth is greater than 0, and in addition I'm taking the condition df is percent growth equals 1, then take the value as df growth. Alright, so this is done. So this is the growth value. So if it is 0, then it will take the same value. If it is greater than 0 and percentage is set to 0, then it gives the value multiplied by a certain number. And if the growth is greater than 0 and its percent growth is just 1, then just give the df growth. Let's take the growth increment unit. Let's also, we are taking inside case and statement. Let's define this case. So we are saying when let me copy this up and let's put it there. We will tweak it. So if the df dot growth is 0, we will say size is fixed. Alright, so this file cannot be grown. And if this condition is true, what we will write is, we will write growth value in MB. So that multiplication was done to show the value in MB. Now here, if this condition is true, we can take growth value in percentage. So these parameters is percent growth is defined as whether the growth is defined in percent or growth is defined in MB. So that is indicated by this section. So against this and remove this comma and we are fine. You can save down this query if you have read it. Let's execute it. So it will give us the data. There is some incorrect syntax. So this dot should not be here. So I think we should be fine now. So there's an invalid column, file name. So let's take file name as the column is df.name, not df.file name. Let's execute it, not should execute. So it gives us a data regarding the TempDB. So it is showing us data regarding the 8 files and including the log file as well. And it is showing the current size in MB, right? Which is calculated using this formula. Auto growth is set to on every file, and growth value is given over here. What is the growth value? And whether the growth value is specified in MB or growth value specified in the percentage. So increment unit is in MB. So yeah, guys, this query is very useful. You can note it down, save it somewhere. I hope you have write it down. If not, please write it by watching this section again on writing the query. Now, this basically gives the details on the TempDB database file allocation. You can check the same details via the properties window file section. You can check this file section out. These details are given over here as well. So that is fine. The same can be obtained through query as well. Now put the TempDB database. All right. So another way to improve performance from a TempDB database is we should put the TempDB database on a fast IO subsystem, possibly on an SSD storage or any other fast storage. We should keep the TempDB files there on a fast storage. And we may also use the disk striping if if there are many many directly attached disk on the system, then we can use disk striping. And one more thing is that individual or group of TempDB data files don't necessarily need to be on different disks. So there's no need to put the TempDB files or group of TempDB files on different disks or spindles unless you are encountering some kind of IO bottleneck. Don't put the TempDB files on separate disks. So unless there are some IO bottlenecks, don't consider putting the TempDB files on separate disks. And put the TempDB database on disk that is different from the disk that the user database use. So that is another point. Put the TempDB database on disks that basically differ from the disks that has user databases. So we should keep TempDB databases on separate disk, other than the one where the user databases reside. We can put the TempDB files over there. Now let's talk about some of the capacity planning in SQL Server. Let's talk about capacity planning a little bit. Capacity planning for TempDB, I would say. So let's mark it with some different colors. So let's take this color. Sorry guys. Let's remove it. I don't know. It is marked. So what if we have to remove a highlighter? No color, and I need to change the color. Let's change it to this color. Okay. Let's start with capacity planning. Let's take color as let's try to take this color and see. Yeah, this one is also good. So let's talk about capacity planning, and we are discussing it for TempDB. We are discussing about the TempDB capacity planning in SQL Server. So give attention here, guys. Let's take a different color pattern. Now, determining the appropriate size of TempDB in SQL Server production environment depends upon many factors. So, determining the size of TempDB in a SQL Server production environment depends upon many factors, right? So there are multiple factors involved in determining the size of the TempDB inside any of the production environments. And uh, these factors include the existing workload, how much existing workload do we have, and the SQL Server features that are being used. So depending on that, we decide upon the size of the TempDB. And basically, recommendation is that you analyze the existing workload. How to analyze the existing workload, guys? There's a recommendation regarding that. You can analyze the existing workload by performing the tasks or performing the following tasks in a SQL Server test. All right. So what are these tasks? Let's touch upon them. So guys, let's review this topic once again. So we were talking about the capacity planning for TempDB in SQL Server. So in order to determine the size of TempDB in SQL Server production environment, it depends upon many factors. What should be the appropriate size for the TempDB? And basically these factor includes the existing workload in your environment and the SQL Server features that are being used. That on these features, it depends how much should be the size of TempDB. Now there are certain recommendations. So recommendation is that you analyze the existing workload. So we are talking about some of the recommendations where you can by which you can analyze the existing workload by performing the following task in SQL Server test environments. So what we should do, we should perform the following task in the test environments. So the first thing that we should do is we should set the auto grow option to on for TempDB. So first thing we should do is set auto growth or auto grow for TempDB. It should be turned on for TempDB in order to analyze the workload. Then what we will do, we will run the individual queries, or maybe we can run the workload. All right, in the test environment we are talking about. So we can run the workload trace files and monitor the TempDB space use. Then what we can do, we can execute the index maintenance operations such as rebuilding the indexes and monitor the TempDB space usage. All right. Another operation we can run is so in this way we should predict the total workload, and we should altogether consider all the workload, and then we set the after considering all the workload, we then specify the size of the TempDB database. All right, so this is the way you should be gathering the or configure the size of the TempDB database. We should put some workload on the system. We should execute some index maintenance commands, and then at the same time we should check for TempDB usage. So there are certain queries which we can use to monitor the TempDB usage. So let's talk about the monitoring of TempDB usage. All right, so let me highlight this topic with a different color. Let's take maybe some good color for this. I think blue one is quite good. We were using it earlier. So now we are talking about how you can monitor the TempDB use. So running out of disk space in TempDB can cause significant disruptions in the SQL Server production environment. So let's talk about this. Running out of disk space in TempDB can cause significant disruptions in the SQL Server production environment. So we encounter many situations where the space in TempDB gets exhausted, and even all the space where the TempDBs reside gets exhausted. The space on the drive gets exhausted, and this can cause significant disruptions in the SQL Server production environment. And basically, it can also prevent applications that are running from completing the operation. So it can also cause applications that are running from completing operations. All right. And basically there is a view which we can use to see the space usage by the TempDB file. So there is a dynamic management view available to monitor the disk space that is used in the TempDB file. So the name of this dynamic management view is dot dm underscore db file space usage. This is the name of that view, and let me ignore for the spellings. So this is the view which we can use, and let me take you through some of the examples. Basically, some sample scripts that I will write to find the amount of free space in TempDB, the amount of space used by the version store, and the amount of space used by the internal objects, and the amount of space used by the user object. So I will segregate the space according to the I will segregate the TempDB disk space being used by various objects. So let me take you through a practical. You can write the queries along with me. So let's close all these queries. Let's see if this property is turned to on. Let me turn it back off. So kindly ignore this, guys. I've done it for some other practical. So I'm turning this option off and just doing a restart of SQL Server. So alright, it's starting. After start, we will continue with the practical of how to monitor the TempDB disk space usage. I will write in some queries, so you may write those queries along with me. So let's wait for it to complete its reboot. So alright, reboot is done. Let me close off these queries. So I had given you this query. I hope you have saved it. So we can save it with the name TempDB auto growth settings, maybe. TempDB auto growth settings checks. Right. Let's close it. Close this one as well. Let's all together launch a new query. So guys, please write some of the stuff with me. So we will write the first script to determine the amount of free space in the TempDB. So write this script. So we start with the select statement. We will do a sum of, first of all, the table we are selecting basically is a dynamic management view. So let's use tempdb dot assist dot dmdb and dm underscore db underscore file space usage. All right. So this is the table name. So let me select certain columns. So I'm selecting the unallocated extent page count, which basically provides us the free space. It is given by the unallocated extent page count, and we can take it as name it as free pages. All right. Second column we would like to take is another sum. So let's take a sum of the same thing, unallocated extent page count, and let's multiply it with 1 divided by 128 to get the free space in MB. Otherwise free space come in extents, so we multiply it by 1 by 128 to get the free space in MB. An extent is 8 extent consists of 8 pages, and one page is 8 KB in size. So 8 KB into, we can say 8 8 are 64. All right, let's try to gain this information. So this will gives us a free space. So right now it's saying that free pages are 13072, and if we try to multiply it with, so these are pages and the page is 8 KB in size, right? So let's try to calculate. So if the page number is 13072 and if we have to multiply it by 8, so this is the size in KB, guys, right? Because a page is 8 KB in size. And if we want to convert it into MB, we can divide it by 1024, which gives us the space in MB. So it's come down to 102.125. So this is the disk space in MB, and this is the calculation being used to get the space in MB. So basically we take the sum of whatever the KB is allocated. So this is as per calculation making the space in MB. You can check that out. So I think basically we are dividing the MB size 1024 divided by 64, I would say. Oh no. But yeah, this one is calculating the free space in MB, and I've performed the calculation. So if free pages are, we are just taking the sum as free pages. So free pages are 13072, and if we multiply by 8, it gives us the size in KB, which comes down to this, right? So if we take a sum of this, right, and multiply it by, maybe we can multiply it by 8 to get the size in what, size in KB, and finally we can divide it by 1024 to get the size in MB. Let's see if we get the same size. So yeah, it almost has given us the same size, but it has removed that decimal part. So if we divide 1024 divided by 8, it comes down to 128. That's why we had taken 128, 1 divided by 128 earlier. It's similar to 8 divided by 1024, which gives us the space in MB. And this is the dynamic management view we have used, and we have just appended TempDB because we are calculating the space for the TempDB database. So currently we see the TempDB has 13072 free pages, and each page is 8 KB in size, and so for the free space in TempDB is 102 MB. Let's save this query. So let me mark it as TempDB checks. So first query is to determine the amount of free space in TempDB. Now let's write another query, which is to determine the amount of space used by the version store. We talked about version store earlier uh, in our theory. So what is version store? Uh, we mentioned about it. Uh, so version stores, here we talked about it. Basically, it is a collection of data pages that hold the data rows that support the features of row versioning. So versions row stores support that if we are using the row versioning feature, and versions row are basically collection of data pages. Now, if we want to determine how much space is being used by the version stores, what we can do, we can write the same query. So copy this out. We will make slight adjustment into it. Let's paste it out. So view used will be the same, right? And basically this one will change. So earlier we had taken unallocated extent page count. Now what we will take, we are trying to determine the amount of space used by version store. So we will take a different column. So column will be version store reserved page count. So whatever pages are reserved by the version store, we can take that out, and we can put it in here, and let's modify it a little bit. So we can say version store pages used. It's not free pages anymore because these are reserved. So version store pages being used, and version store space in MB, space used in MB, we can say. We can take it like this, save the query. Now run this query. So right now we are not using any kind of row versioning, so any of the pages are not reserved by version stores, and therefore no space is being used by version store here. Otherwise, if you can keep this query, you can write it down and keep all the four scripts together to determine the space allocation of TempDB. Now let's write another query where we will determine the amount of space being used by internal objects. Alright, so what should be the query? Again, copy the same query, paste it here, and we will make slight adjustments. So here we are using internal objects, so we will take internal objects reserve page count. So let's select this, type in internal, so it will give you internal object reserve page count, and copy this out and replace the second one with the same text, and let's change it here. So earlier it was written as version store pages used. Now we will just change it to internal objects pages stored, pages used. So let's change it to internal objects. So internal objects are the objects used by the SQL Server Database engine, and SQL Server Database engine uses the TempDB database to store these internal objects. Let's see if any of the space is being used by the internal objects. So we see SQL 8 pages are being used, and these are not using much space, so it's less than 0 MB. That's why. So if we want to see in decimal, we can put it like this. I think it should show the decimal part then, maybe. Yeah. So the total space used by these 8 pages is 0.062 MB, which is not much. Now let's write another query to determine the amount of space being used by user objects. So these are the objects created by user. Let's copy the statement out here and we will make little changes. So just select this and type user, you will get something. So we got user object as a page count. Copy this item and replace it here. All right, and we will make slight modification. So instead of internal, we are using the user objects. Same for this one, type user, and we are done. We can execute this, and right now we can see that the user objects are using 256 pages, and the total space being consumed by these pages is around 2 MB, which is at present quite less. So guys, you can save out all these 4 queries. These can be used in production environments as well to check out the space being used by various objects, the TempDB space being used by various objects. Let me close this out. I hope you have noted it down. If not, please go through the video again and write these queries down. Let me close this. So you can also monitor the page allocation or deal allocation activity in TempDB at the session or task level as well. You can use the sys.dm_db session space usage, or maybe sys.dm_db task space usage, dynamic management views. So there are other 2 dynamic management views available as well. So let me write those down. So these are sys.dm_db. Earlier was one for the file space usage. So if you want to know the session space usage, that is for a specific session, and we want to know what space is being used by that particular session, we can use this dynamic management view. And also there is another dynamic management view, which is dm underscore db task space usage, and this basically shows us the space used by any particular task, and these two are the dynamic management views. And these views can help you identify large queries, any temporary tables, or table variables that are using lots of TempDB space. All right, we are talking about these two particular views. So the above two views can help you in help you identifying large queries, temporary tables, or table variables that are using lots of TempDB displays. And we can also use various counters to monitor the free space that is available in TempDB and the resources that are using the TempDB. So there are several counters available. We are not covering it here. But yeah, let's move ahead. Let's discuss one more example. Basically, will be a script to obtain the TempDB space consumed by internal objects in all currently running tasks in each session. So we will use the task space usage dynamic management view this time. So we will use this view to obtain the TempDB space usage consumed by internal objects in all the currently running tasks in each session. So let's open up SQL Server. We had saved the query. Let's open it and write it there only. So documents, maybe. I don't know where I have saved the queries. Sorry guys. Maybe in code snippets. I don't know where I've saved it. Let's see. So I've saved it here. TempDB checks SQL in the document SQL Server Management Studio. It should be there. So right now the type of file selected is execution plan file. So I need to change it to SQL file. So let's check it inside the SQL Management Studio, and TempDB checks is the query I'm using. So earlier I had written 4 queries. Now let's add some more queries to it. Let's obtain the space consumed by internal objects in all currently running tasks in each session. So for this we use a different dynamic management view. So the dynamic management view is sys.dm underscore db underscore task underscore space usage. So this is not particularly tying up to TempDB like we have shown earlier. So this in general will take all the databases and will let us know what all internal objects are consuming data space. So let's select the session ID, which session ID is consuming how much disk space. Rest of the item can be same. So we can take the queries for the internal objects. So let's take this 2 lines. Let's take these 2 lines. Yeah. So after session ID, you can select these. Now let's run this and see if you can get anything. No, there's slightly difference. Session ID, internal object. Here, we don't want to see the reserved page count, but instead, we want to see the allocated page count. So change it a little bit here, and it's objects, and instead of reserved, it's allocated. All right, and we will take it as something different. So we will take it as, basically we are taking it as task internal objects. This will gives us the allocated page count basically for the internal objects. And similarly we can check the, we don't want it in MB. We are just taking the allocated page counts. We are not converting it to MB. So similar to this, what we can do is we can copy this and paste it here. And instead of allocated, we can see the deallocated as well. Deallocated page count. How many pages are being allocated and deallocated? This will gives us an idea of that as per the session ID. And let's take it as deallocated page count. So let's mark it as this, and I think the stored procedure is correct, right? And looks to be correct. Task space usage and comma should not be there after the second select statement, and after that we can group it by the session ID because we want to see the count by session ID. So let's execute this statement. So right now if you see, there are various session IDs currently being running, and it shows us how many internal objects under each of the session ID are allocated any of the page counts. Any of the pages that are deallocated are shown under the third column. So there's nothing currently allocated or deallocated to any of the sessions, to any of the internal objects used by SQL Server. Now you can run another script uh, as well. I think we can ignore that. So just keep it till here. These many queries should be sufficient enough to check on the TempDB database usage. So guys, we are done with this video. I hope this video was on TempDB. We have discussed about TempDB in detail. So what all we have covered, let me show you quickly. So we have started off with TempDB discussion. So we talked about little bit about the TempDB, what it holds. It holds some temporary user objects, the internal objects, as well as it stores the version stores. And we talked about the operations within TempDB. These are minimally logged, and how it gets recreated every time the SQL Server is restarted. And we talked about the restrictions applicable on the TempDB. We cannot do certain things with TempDB. We have discussed a list of items that we cannot perform on TempDB. Then we discussed about the optimization part of TempDB performance in SQL Server. We have discussed about various methods with which you can increase the performance of TempDB. And later on, we have discussed about the capacity planning for TempDB in SQL Server, how we perform the capacity planning. Then we discussed on how you can monitor the TempDB usage. We have given you certain scripts to monitor the TempDB disk space usage by various type of objects like internal objects, version stores, and any other user objects. We have talked about 3 dynamic management views as well. But yeah, we have shown you practicals on only 2 dynamic management view. One is the sys.dm db file space usage and sys.dm db task space usage. We have used these 2 views, dynamic management views, to show you some practicals. So guys, we are done with this video. I hope you like this video. This was the video on TempDB database. And let me go back to slide. I thank you so much for your time on this video today, guys. If you have not already subscribed to my channel, or if you are new to this channel, what I would suggest is please go ahead immediately and click on the subscribe button below this video. Once you click on the subscribe button, you will get a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. And apart from that, guys, do share your comments with us, any suggestions, any requirements, any your day-to-day experiences with SQL Server, any situations where my videos become useful for you in many of the day-to-day situations. And also please share this video with your friends. YouTube provides the share button to share this video with your friends. You can share these videos over WhatsApp or any other medium. maybe Gmail or any other medium. You can share this video with your friends. If you have a good network of friends, please share it with them. If they work in SQL Server domain, also please ask them to subscribe to my channel in case you feel my videos can improve their life or make difference in their life. Please do share my channel link with them. Ask them to subscribe to my channel as well. So guys, we are done with the test video, and this was on TempDB database in SQL Server. I hope you like this video and you have a wonderful day ahead, guys. Thank you.